we start considering a quantitative variable x and O of x, which is a list of x measures in ascending order. Then we consider S of C, which is the sum of absolute residuals of every observation of O of x respect to C. And we define M as the median of those observations. And we remember also that the median is defined as the element in position half n if n is odd, and every element between the element in position half n and half n plus 1 if n is even. With those information, we want to show that the value assumed by C that minimizes the sum is indeed the median. To show that, we will derive the function. But first, I want to split the module to make the calculation more easy. So this is our data set, already ordered, as previously said. And we imagine to choose an arbitrary C. Then we have k elements which are less than C, and n minus k elements which are greater or equal to C. Now we can easily split the module. So the sum is equal to the elements from 1 to k of C minus x plus the elements from k plus 1 to n of x minus C. Okay. Now we can take the derivative with respect to C, of course. So we have derivative of the first summation plus the second. So x of I minus C respect to C. Now we remember that the derivative is a linear operator, and so the derivative of a sum is the sum of derivatives, and so we just write that again in this way. So this is again the first sum plus the derivative of the second. So k plus 1 to n x of I minus C, always respect of C. Okay, now again, for the last time, I swear, we remember that the derivative is again linear, and so we can take the derivative function inside the summation. And so we have sum of the derivative of C minus x plus the second sum of the derivative of x minus C. Okay, now those derivatives are trivial because x of I is a constant and C is simple C, so the first derivative is simply the summation from 1 to k of 1. And if you notice the second, it's pretty much the same, except there's a minus in front of C. And so I take already outside of the summation the minus, and I just write nearly the same thing. So from k plus 1 to n of 1. Okay, we are already done. So these summations are trivial because in one case you sum 1 k times, and in the other you have to subtract the sum of 1 summed n minus k times. So the result is 2k minus 1, which is equal to the first derivative of the summation respect of c. Okay, now we can notice a strange thing. The derivative is in function of c, but there isn't a c here. We just have k and n. N is a constant and k is a variable. But we remember that k is strictly related to c, and so now we study this function in function of k. We call this f of k, and this is the derivative, so we just want to study its signs to find the function, the original function minimum. And to do that, I think that's easier to just plot it in a simple plot. So we notice that this is a straight line. N is just a constant, so if k is equal to 0, so we just write the axis down. If k is equal to 0, the function has the value of minus n. But then as k increases, it has a coefficient of 2. So this is something like the function. Okay, now it's almost done. We just have to notice that this point, so when the function is equal to 0, is equal to n divided by 2, because we just say that the function equals 0 and we find the point, so k equals half n. Now we notice that to the left of this point the derivative is negative, and to the right of this point the derivative is positive. And that means that our function s of c is done this way. So here we have half n, and the function is decreasing, here is increasing. So this means that for the element in position x of half n, we remember that half n is an index, so k, that means that x of k, but in this case k is half n, is a point of minimum. And so this quite close the proof, because as we said before, this is really the definition of median, because the median is either the element in the position half n or every value in between the element in position half n and half n plus 1. And we already found that this is a minimum, and this is right the definition of the median. So this closed the proof.